Welcome to week 5, assignment 5 hints and solutions. So if you look at the first problem, the shapes given are geometrically similar. I think that should be the answer. Second one, I'm not very sure. Anyway, these theoretical concepts and all, like you have to read some book, and because there are many options here, I'm not sure which of them are correct, and I don't have uh, the motivation also to do. I'll want to focus more on problems. So anyway, I'll upload a book here. It's called White. I'll upload it on Drive, and you may find your hints for the problem number 2 over there. First one, I think it should be just they're geometrically similar because if you see the stars and all, the dimensions and all are reducing, but they are geometrically very similar. Second one, like I'll upload this book. Like if you see over here, a lot of theory is given. So maybe just go through chapter 5 theory. Yeah, I've not gone through it fully, but I think I saw some of the terms that are being used in this question. I saw in chapter 5. So maybe just go through this dimensional analysis and similitude, especially this part, flow similarity and model studies. You may get your answer over there. Oh, sorry, this is Fox Pritchard, not Fox Pritchard. I wanted to go through this book, White. Fox Pritchard, I've already uploaded it. But they are more numerical questions are given. This is an entirely theoretical question. Yeah. From page number 321 onwards. So for the theoretical background, okay, all this, especially these bolted parts and all, this red parts and all, you can go through. It may help you like kinematic similarity, dynamic similarity, etc. Okay, so it may help you solve question number 2. Okay, so third question onwards, like we can see, we can try to solve them numerically. So a 1/6 scale model of an automobile is to be tested in a wind tunnel at a speed corresponding to the prototype speed of 60 kilometers per hour. Assuming that only inertial and viscous forces are to be modeled, calculate the following. Okay, and there are a few subparts here. Question number 3, 4, 5, 6, 7. Okay. So what are the parameters here? They have talked about inertial force, viscous force. Then here they have talked about drag. Okay. So drag is basically force. So let us first apply the Buckingham Pi theorem and see what dimensionless groups we get. And then we'll solve it. Okay. So inertial and viscous forces to be modeled. They have also talked about drag. So what is the dimensionless number? And then some numericals and all. Okay. So if we take, we'll apply the Buckingham Pi theorem. Okay. To get the functional dependence. So what are they? What are the dimensional parameters? Force, velocity, diameter, density, viscosity. Okay. So n is equal to 5. That is, there are 5 dimensional parameters. This is the first step. Second step, what are the primary dimensions here? We'll follow the same process as the Buckingham Pi theorem. What are the primary dimensions? Mass, length, time. Okay. So let us just first break it down, each of them. What is force? What is velocity? What is diameter? Rho, mu. Force is mlt minus 2. Velocity is lt minus 1. Diameter is L. This is ml minus 3. This is ml minus 1. T minus 1. So what is J over here? J is 3, right? Because we can take three of them, three of these variables, say rho, v and d, rho, v and d, and we can't form a dimensionless group. So J is 3 here. So how many dimensionless groups you will find? N minus J is equal to 2. So you'll have 2 dimensionless groups. So let us apply Buckingham Pi theorem. So let us select rho, v and d as the repeating variables. Okay. So what is pi 1? Rho to the power a, v to the power b, d to the power c into force. So this is dimensionless, right? M0, L0, E0. So find ABC now. You know what is rho, right? Rho is M L minus 3 to the power A. D is LT minus 1 to the power B. D is L to the power C into force is equal to M to the power 0, L to the power 0, T to the power 0. Sorry, what is rho here? F is what? MLT minus 2 now. So by, let us now break it. M will have what power? A plus 1. L will have what power? Minus 3A plus B plus C plus 1. T will have what power? minus b minus 2. Okay, so this is nothing but equal to m0 L0 T0. Hence, equating the powers on both sides, a is equal to minus 1, b is equal to minus 2. So what will c be? C will be 3 minus 2 plus c plus 1 is equal to 0. So c will be minus 2. Now putting ABC and in this pi 1, calculate pi 1. It is pi 1. Pi 1 is basically f divided by rho v square d square. Okay. So similarly do it for pi 2 also. Pi 2 will be what? Rho to the power a, v to the power b, t to the power c into mu is equal to m0 L0 T0. What is rho? ml minus 3 to the power a. V is what? Lt minus 1 to the power b. L to the power c. ml minus 1 t minus 1 to the power 1 is equal to m0 L0 T0. So m to the power a plus 1. L to the power minus 3a plus b plus c minus 1. T to the power minus b. So if you see from here, a is equal to minus 1, b is equal to minus 1. Just plug all this, you get minus 3a is minus 3 into minus 1. So 3 minus 1 plus c minus 1 is equal to 0. Or c is equal to minus 1. So what is that second dimensionless group? Mu divided by rho vd. What is mu divided by rho vt? It is 1 by Reynolds number, right? I hope you are getting this. Just solve it on your own, you'll get the same thing. So the functional dependence, like you can write pi 1 is some function of pi 2. We don't know the nature of the function, but we know that it depends on the other dimensionless group. So pi 1, which is f divided by rho v square d square, is some function of 1 by Reynolds number or Reynolds number. Same only. Because it's dimensionless, right? So what should be the first part according to the question? Which among the following numbers needs to be same in order to perform the comparison? So only Reynolds number we are getting. Reynolds number in both have to be same. So as I said in that book, like the book that I'm going to upload, just read about dynamic similarity, kinematic similarity, etc. Model prototypes, some solved examples will also be given. Just go through all that. So here they have told that what should be the wind speed, that is fluid velocity, at which the model automobile should be tested. Note that the fluid around the model automobile and the prototype is same and is air. Repeat your answer in kilometers per hour. Fine. Okay. So that's question number 4. Basically, these two dimensionless groups indicates that uh, Reynolds of the model should be same as Reynolds of the prototype. And if this holds true, then the other dimensionless group f divided by rho v square d square model is equal to same of the prototype. Fine. These are the dimensionless groups that we've got, right? And he has already told that from the question, the prototype speed is 60 kilometers per hour. V prototype is given. V prototype is 60 kilometers per hour, or 60 into 10 to the power 3 meters per hour. Hour has 3600 seconds. This is meter per second. And they have told that fluid around the model and the fluid around the prototype is same and is air. That means the rho and the mu for the model and the rho and the mu for the prototype both are same, both are air. So we don't have to worry about that. So what is Reynolds number formula? We just have to equal the Reynolds number in both cases. Reynolds number formula, if you remember, it is just rho Vd by mu. And in both cases, they are saying rho is same, mu is same. It's same in both model and prototype. Rho air, mu air. Okay. So we just have to equate V into D in both cases. So since the Reynolds number in model and prototype should be same, Vd model should be equal to Vd prototype. Okay. D is the length scale involved here. V is the velocity. And they already told that model length scale is prototype length scale divided by 1/6. It's 1/6 of the prototype. So if prototype is 1, this will be 1 by 6. If prototype D is 1, this will be 1 by 6. Because model is only 1/6 as big as the prototype, right? The velocity of the prototype we have told is 60 kilometers per hour. Okay. Okay, let us not break it into. They have asked in kilometers per hour, I think. Report your answer in kilometers per hour, right? So let us not complicate matters here by putting meters per second and all. Let us report as they have asked in this one. So V model is we have to find. It's 1/6 the size of the prototype. V prototype is 60 kilometers per hour and D is 1. So V model will be what? 360 kph. See in the question they have already told clearly that report your answer in kilometers per hour. So you have to be mindful of the units. So V model is 360 kilometers per hour. So likewise, so what's the next question? If the model drag at the speed of 510 Newton, what will be the drag on the prototype? Report your answer in Newton, right? So I'll just make a comment here that the forces are not same. The dimensionless numbers are same. So I will write it in text form. Okay. Okay. So F prototype is not equal to F model, but F divided by that rho v square d square, this dimensionless group that we obtained from the Buckingham-Pai theorem, that is same for both. Okay. Okay. So they have, what's the question now? Question is, if the model drag at the speed, at that speed is 510 Newton, what will be the drag on the prototype? So model drag, they have told that it's 510 Newton. And they've asked you to calculate the model prototype force. So another thing you have to make note here is that rho will be same in both cases, right? But v and d will be different because model and prototype have got different velocity, different dimensions. So let us just go by the problem. 510 force of the model. Rho is same in both cases. So what is Vd for the model? That whole square. This we have to find out. So prototype velocity we already calculated. We already know, right? From the problem. It was given that was 60 kilometers per hour. You know, prototype V we know it's 60 kph. We know model V, that is what we found out here, right? 360 kph. And we also know that diameter of the model is 1/6 of the diameter of the prototype. So what is VD model? VD model is nothing but 360 into 460 dpl. And what is VD prototype? 60 into D prototype. So we see that VD model and VD prototype are same. So this value and this value are same. So FPR will also be equal to 510. So from here, if you see 510 by VD prop whole square is X, whatever you want to calculate, right? Sorry, this is model. They're basically told that the model drag speed is at 510, so they want to find the drag force on the prototype. So this and this are same. So X will also be equal to 510. Okay. So now is the sixth question, the power requirement. And after that, these are all simple. So just maybe we'll take some short break, then we will resume from the sixth problem. Okay. Okay. So maybe just try to find out how you can equate force and power. What is a unit of power? What is a unit of work? What is the unit of force? And how you can relate with the known information. So after the break, I'll meet you and I'll tell you how to do it. Mm. So we calculated the drag force for both the model and the prototype. And we know that the surrounding fluid is what? It is air. It is same in both model and prototype. And it's going with some velocity v. So what is power, you think? How do you relate it to force? So force, if you know from Newton's second law, is mass into acceleration. Acceleration for rate of change of velocity. Delta v by delta t, rate of change of velocity. So what is work now? Force into displacement. And power is what? Force into rate of change of displacement. What is rate of change of displacement? Nothing but velocity. So power is what? Force into velocity. So they are asking what is the power requirement to overcome the wind drag of the prototype automobile? And the units they want is kilowatt. Okay. So what is the second? Yeah. So what is the prototype velocity? It is given in the problem. It is 60 kilometers per hour. And what is the force in case of the prototype as well as the model? We found that both are same. Both are equal to 510 Newton. So force is what? 510 Newton. Velocity is for the prototype is 60 kilometers per hour. But they have asked in kilowatts. So first you have to convert it into SI unit and divide by 1000. So 510 Newton will remain as it is. Kilometers per hour is what? 1000 meter in 1 kilometer. And 1 hour will have 3600 seconds. So basically it is 510 into 60 kilometer per hour to meter per second is 1000 by 3600. And this is what? This will be in watt. So to convert it into kilowatt, you have to divide this entire thing by 1000, right? So it comes to 8.5 kilowatt. Just check it once. This is the answer that I'm getting, 8.5 kilowatt. So next question is, a simple approach to consider the effect of particle shape in fluid particle system is through sphericity. Consider a cube with each side of 1 micrometer length. The density of this cube is 1000 kg per meter cube. Calculate the sphericity, right? So you have to calculate the sphericity for the seventh problem for the cube. Okay, so if you go to this lecture by Basavraj sir, characterization of particles part, second part, you'll get the formula for sphericity. So how he has defined sphericity is Sp by Vp for spherical particle divided by Sp by Vp of a particle nominal size like dp it will be, right? Nominal size for both should be same, right? So you go around this 31, 32 minutes time mark of that lecture. So this is the formula for sphericity. Sp by Vp for sphere divided by Sp by Vp of cube.
Your volume of the cube is a cube, right?
The volume of the cube will be equal to the volume of the
I'm going to
sphere.
equate that to the volume of a sphere.
Okay. So basically a cube is equal to is Sp by Vp of a sphere. Sphere surface area is 4 pi r square. Volume of sphere is 4 by 3 pi r cube. So it's basically 3 by r. And for cube, if you do Sp by Vp, so there are 6 surfaces in a cube, right? If I take a cube, sorry, like they all should be equal. Cube means equal length size, L. So this is one surface. Opposite to that will be one surface. This is one surface. Opposite to that will be one surface. This is top surface. Opposite to that will be another surface, right? Okay, say it's A, not L. It's A. Each side is A. So it will be basically 6a square divided by a cube or 6 by a, right? And what is A? So now what is the sphericity formula? It's basically Sp by Vp of the sphere divided by Sp by Vp of the cube. Sp by Vp of the sphere is nothing but 3 by r. And for the cube is 6 by a. So it will be a divided by 2r. And the relation between a and r you know here. A cube by r cube will be 4 by 3 pi. So a by r is equal to 4 by 3 pi now to the power 1 by 3. So from there you can calculate the phi. And he has already done it here, I think.
Okay. And what you
Think he got value as 0.806 or something. So you'll also get similar value. Just check it
so
once.
if you work it out, it
It will be 0.806 or something. So just work it out, okay? So that will be the answer for this one. The seventh question. So eighth question. Select the SI unit for surface area. So SI unit for surface area is what? Surface area is what? Area. Area is what? Length square. Length unit is meter. So meter into meter is meter square. For 8, it will just be meter square. Likewise for 9, pick the correct SI unit of specific surface area from the following. Specific surface area, I already told that it means a meter square per mass. So meter square by kg it will be. Okay. These are all very straightforward questions only. So let's go to the 10th question. So you have to find specific surface area of a sphere, and that sphere has got diameter 1 micrometer and density 2000 kg per meter cube. So diameter of that sphere is 1 micrometer, and what is rho? The density of that sphere is 2000 kg per meter cube. You notice the sphericity formula, how we arrived at density does not play a role. So if you see the question, like they have given the density also in this case. The seventh case where they asked you to find the sphericity, they have given the density also, but density has got no role. So just to confuse you, they have given density. But here density will play a role. Okay. What is specific surface area of a sphere? Silica particle, diameter is given, density is given, and the specific surface area unit will be meter square per kg. So this also answers this question. See, specific surface area, what is the unit? And here they have already given specific surface area unit is meter square per kilo. So if you know 9, if you just see the question, you don't even have to know it. Just see this question, meter square per kg, this directly answers your question number 9, right? So coming to 10 now. Again, this here solved, I think. This here given the formula, I think. What is specific surface area? Area of the sphere. What is area of sphere? 4 pi r square divided by the mass of that sphere. Mass is what? Volume into density. 4 by 3 pi r cube into rho. 4 pi gets cancelled. There is only 1 r. So 3 divided by rho r. Right? That is what he must have got. Yeah, 3 divided by rho r he has got. So this is the specific surface area of the sphere. And what is it here? It is basically just 3 divided by 2000 into r. R is what? Diameter is 1 micrometer. So r is 0.5 micrometer. And what is micrometer? 10 to the power minus 6 meter. Right? So 10 to the power minus 6 will become 10 to the power 6 in the denominator. So it will be 3 to 10 to the power 6 divided by 2000 into 0.5. What is 2000 into 0.5? It is just 1000. That's 1000 or 3000. Okay, so this is the 10th question. Okay, so I hope we have already seen solved question number 3, that is Reynolds number, 4, 5, 6, 7, everything we have solved. 8, 9 also we have solved, 10 also we have solved. So one I already told you that they're geometrically similar. 2, I'm not sure. I tried doing it, but like I don't want to commit myself with an answer because it may be wrong also. There are many options. So as I said, just refer to this book by White. Read this part of his, especially this page 321 onwards. You read it, modeling and its pitfalls. I'll upload it shortly, and you may be able to solve. I'm not promising anything, but there is a chance that it can be solved like that. Okay, that's it then. Thank you.